And now we have to see the signals. So if it's R-type instruction, so the R-type instructions opcode is shown up here. So this in this slide, what we are going to discuss about the control signal. So what do you think will be the value of this reg-write signal? We are talking about the R-type instruction. Yep, it would be 1. Why? Because in R-type instruction, it always write the data back to the register. Okay. What about mux? Where the second input of ALU is coming from? From the register or from the offset value? Yep. From the register. From the register. So the value should be 0. Okay. And then talk about the ALU operation signals. So this control unit generates a 2-bit ALU op signal, which in turn generates a 4-bit corresponding ALU control signals. We have already discussed this, so I'm not going into detail. So depending on what type of R-type instruction it is, add, sub, and or, it will generate the corresponding signal. But what about the memory? So this instruction, this control signal is mem read, and this one is mem write. What will be the value of mem read and mem write signal? 0. Both are 0 because in R-type instruction we do not access memory. Okay, we do not neither write or read from the memory. So both of them should be 0. What about the mux? Here, this mux. What will be the value of this one?
0.
Should it be 0? Yeah. So because the data that we want to write is coming from the ALU. Okay. What about this? The AND gate. This branch signal would be 0 because this is the R-type instruction. Controls unit will generate, will specify branch signal as 0 because it's not a branch instruction.
For R-type, you're just going to the next instruction, right?
Yeah, it's going to the next instruction. So because of this 0, it will select the PC plus 4 as the address of the next instruction. Okay? Any question? Okay. Okay, so these are these values. In case of LW, what do you think should be the value of register write? Why? It's 1 because in LW we read the data from memory and write it into register, so it should be 1. What about this one, this mux? What should be the control? Again, we are just practicing with this. I might in exam replace these 0 with 1 zeros. Okay, so again be cautious about it. So what do you think will be the select signal of this mux? From this side, anyone from this side? Yep. 1, it will be 1 because LW has an offset value. Okay, so offset is data, immediate data that should be coming from this port, so it should be 1. And then ALU generates some signals. What about the data memory signals? Yep.
Would it still be 1 if it's switched like you said? Like the 0?
No, if I switch it to 1 here and 0 here, then it will be 0. Okay. While looking at the mux, look at these signal values. Okay, so if it's an LW instruction, so for example, you get a question in exam, and if I swap this value with 1 and this value with 0, and if it is the LW instruction, then you should be selecting 0, of course, because in case of a LW instruction, 0 will be the value that should be placed at this input of the ALU. Okay, get it? So in this example, this 0 corresponds to the data is coming from the register, and the 1 corresponds to data is coming from the offset value. Okay, so that is why we select 1. But if I swap this, instead of 0, if I have it 1 written here and 0 written here for the same instruction LW, which means that it should be 0 in that case. Okay, what about the memory? Are we reading the data from memory or writing the data from memory? What are we doing? What should be the mem read signal? Mem read is 1, mem write is 0. Okay, so this is 1 and 0. What about the mux, where the data is coming from? What should be the signal value of mux? 1. This was very easy. And here branch is 0 again. Let's do SW. Here it is important. Everything is same. Register write, we are not writing anything. That's why it is 0. It should be 1 because the data is coming from the offset. What about the mem read? We are not reading the memory.
Controls all this.
We are writing the data into memory, which is 1. Okay. What about this mux? What should be the control signal for this mux? Hmm? 1? What? It should be x. Why? Because it does not matter. Okay? Because we are not writing the data into memory. No matter whether the data is read from this port or this port, it will never be writing data into register. Why? Because the reg-write signal is 0. Okay? So it does not matter whether this mux value is set to 1 or 0. It will not be writing the data into register anyway, because the reg-write signal is 0. Okay? And BEQ again is same thing. In this case, this is also x, and this is 1, and if the condition satisfied, this would also be 1. So it again depends on whether the condition satisfy or not. Okay, so we need to start off and yep.
What's the actual like translation significance of the opcode to what we're like choosing here for it to be on and off? Because it's not
Hey.
like a direct correlation. It doesn't look like.
So the control circuitry reads the opcode, and based on the opcode, it sets these signals. If it identifies that it's a branch instruction, then it will set this branch signal to 1, which signifies that this is the branch instruction. Okay? And again, based on the branch instruction, it will, or whatever the instruction type is, it will set this reg-write signal. Whether branch instruction will be writing the data into register? No. So that's why it will set it to 0.
But as far as like the individual bits that are like on and off in that opcode, like those aren't like one-to-one or anything, right?
Those are one-to-one.
Not like one-to-one. Like one of those bits means like branch, one means like memory. Like
So this is only the opcode field.
yeah.
So every instruction has a different opcode. So if it's a branch, it has this opcode. And if you go back, it says SW instruction, it has a different opcode.
Yes.
So it will read, the control unit read the entire 7 bits of opcode, and based on this value that it reads, it sets the signals accordingly.
Do those bits actually correlate to those individual control signals?
Yeah.
They do?
Yeah.
So like why is like on one
I mean,
of the-
what do you mean by correlate?
like if that say if that first bit is on, it means like branch on.
No.
It doesn't mean any of that.
It's not like that. It has to read the entire 7 bit to make the decision what instruction, what control signal should be the values. Okay. Store instruction. This one. Yeah.
So you mind chopping out the path?
Yeah. So again, the instruction opcode will go into the control unit first. It will set the control signals. The check path means like, okay. So it will read RS1 from here, which will be containing the base address. Okay. The second thing is coming from the offset value. That is and these two values are added together to generate the address where we have to write the value. Right? What value that we are supposed to be writing is coming from the register port. Okay. So it will be writing the data in here. Okay. So the SW instruction finish here. Okay. So that's why it does not matter what is the value of this mux is. If it is 1 or if it is 0, no matter. So for example, if we say the select signal is 1, it means that whatever the data is this port, garbage data or whatever, it will go back here and then will be placed here. But will it write it into register? No, because reg-write signal is 0. It will not let anything write into the register. So this is the group activity that you are supposed to be doing now. You will be provided with the processor components in the form of puzzle. You need to put them in the right order. Okay. You are also given these signal values, like signals in the form of arrows, which you will use to construct the processor. Okay. You need to execute the first 2 instructions, one after the other, pointed by program counter. So how do you know which instruction to execute? You will be given the instruction in the instruction memory, so you need to determine yourself what instruction is going to be executed. Okay. Next, write control signal for both instruction, the first 2 instruction I'm talking about. Okay. Write it somewhere because it will help you answer the questions. update register and memory contents for both instructions. So the data is also given to you in the form of data memory. Okay, so you should know when you construct the processor, you know that what instruction is executed, okay, what data you read from the register, what data you are reading from the memory. The data will be given, okay, and then you will be writing it back into the register. So whatever data you are dealing with, just keep an eye on or keep noting it down, what data you're reading, what data you're writing into the register. It will help you again answer the questions. It's a 27 minutes activity, and 0.5% for participation and processor construction. It will be given to the entire group if you complete the processor, and I will keep an eye on who's participating. 0.4% for the quiz. There will be 4 questions in the quiz, and 0.1% for whoever rank 1, just additional as I mentioned last time.